You know, there's a hidden arms race happening right now. It's not for land or for weapons, but for something way more fundamental in our digital world, our information. We are in a massive, high-stakes race to protect everything we do online from a threat that hasn't even fully arrived yet. But its shadow, it's already here. This is the story of the quantum arms race, and believe me, it's moving a lot faster than you think.
So here's what we're going to cover. First, we'll dig into the hidden threat, what's happening right now, behind the scenes. Then we'll explore the two main strategies being built to defend all our data. After that, we'll meet the new digital armor that's going to protect us. We'll see how this is already a reality today, and finally we'll look ahead to what's next in this silent battle.
All right, so let's jump right into the danger. And here's the thing, you might think this quantum threat is some far-off sci-fi problem. But nope, the heist, it has already begun. Seriously, just think about it for a second. Your bank records, your private conversations, even top-level national secrets, everything we lock away digitally is protected by a code that we know, for a fact, has an expiration date. The threat we're facing today has a name, and it's kind of chilling. Harvest now, decrypt later. Imagine a thief steals a locked diary. They can't open it, yet, but they're betting that in a few years, they'll get their hands on a master key that can. That is exactly what's happening right now. Adversaries are just hoovering up massive amounts of our encrypted data, putting it on ice, and just waiting for that key to be invented.
And that master key they're waiting for? It's called Q-Day. That's the moment a quantum computer will be powerful enough to just shatter the encryption we rely on for everything. And the clock is ticking really fast. Most experts are pointing to sometime in the early 2030s. This is why data that needs to stay secret for a long, long time, like government files or your own genetic information, is already at risk. Today.
Okay, so that's the threat. It's a big one. So how on earth do we fight back against something that's still in the future? Well, the Global Defense Plan is basically moving down two very different tracks at the same time.
In one lane, you've got something called quantum key distribution, or QKD. Now this is cool. Its security is literally based on the laws of physics. If a spy tries to listen in on the exchange of a secret key, the very act of observing it changes it, and bang, the alarm goes off. It's incredibly secure, but it's pretty specialized, best for high-stakes sectors like defense. And the other lane is Post-Quantum Cryptography, PQC. This is the real game changer for everybody else. It's not about new hardware, it's just about new math. Really, really hard math problems designed to be so complex that even a quantum computer gets a headache trying to solve them. And the best part? This new math runs on the laptop or phone you're using right now.
For the massive worldwide upgrade that we all need, PQC is the main event. So let's take a look under the hood and meet the new digital armor that's being rolled out.
All right, this is our new digital toolkit, and the key thing to understand is that it's not about finding one magic algorithm. The whole strategy is about diversity. Think of it like having different kinds of locks on your front door. The main ones, what they call the workhorses, are based on incredibly complex geometric grid problems. But just to be safe, NIST also standardized completely different kinds of locks based on totally different math. This diversity is our ultimate insurance policy. If a weakness is ever found in one, our entire digital house of cards doesn't come tumbling down.
And this toolkit isn't a one-and-done kind of thing. It's built to evolve. NIST is basically treating this like a permanent cybersecurity upgrade. Because our best defense against an unknown future is to never, ever stop looking for better ways to protect ourselves. This whole process is called the on-ramp. It's essentially a continuous, open competition to find and approve the next generation of algorithms. In fact, as we speak, there are 14 candidates in the second round of some seriously tough testing, all to make sure our defenses keep getting better and more diverse.
Okay, so that's the theory, but how does this all actually translate into the real world? Well, it's not a future projection. It's happening right now. The move to a quantum-safe world is already a reality you can see and touch.
I mean, just look at this timeline. The speed is incredible. The first official standards were only finalized in 2024. A crucial backup was selected in 2025. And this year, we're already seeing the first mandatory compliance rollouts for critical industries. The race against Q-Day is officially an all-out sprint.
And you know it's serious when the big money starts flowing. The market for just that one physics-based solution, QKD, is already expected to be worth over $1.6 billion this year. This has moved way beyond a niche academic problem. It's a major global investment.
But honestly, this might be the most stunning fact of them all. Right now, on major internet backbones, more than half of the traffic you generate is already being protected by this next-generation cryptography. Let that sink in. This isn't a plan for the future. The future is already here, running quietly in the background on a massive scale.
So the strategy for building this resilient future has a few key parts. You've got government mandates pushing for change, smart hybrid models that use both old and new encryption for a smooth transition, but the most important principle of all is something called crypto agility. It means building systems where you can swap out the encryption algorithm as easily as changing a light bulb. That kind of flexibility is the new normal for digital defense.
So what's next? The first wave of defenses is being deployed, but the work is far from over. This is a constantly moving target. So let's take a quick look at the next frontier.
This is where that on-ramp process gets really creative. The next algorithms being tested are built on completely different types of math. Some are based on solving huge systems of equations, others on coding theory. There's even one based on something called isogenies that creates these incredibly tiny digital signatures, perfect for small, low-power devices. The goal is simple. Build a toolbox so diverse that no single mathematical breakthrough could ever put all our data at risk again. And this brings us to our final thought. As we race to build these new, unbreakable systems, we solve one monumental problem, but we may be creating a whole new set of questions. In a world of truly unbreakable codes, who gets to hold the keys? Who decides what stays private? And what does that really mean for the future of privacy, security, and liberty? That's a question we're all going to have to answer together.